you have a 4x4 square centered around the origin, so you know that this, the side farthest out it goes is 2, right, in any direction, right?
Right.
Inside of it, you have some kind of blob that, and this is the rule for it, is that basically for all the area inside, the distance from it to the origin must be less than the distance from the edges or the sides. Okay? So that means that if you pick any point in here, it should be farther away from this line up here and this line over here than it is from this point at the center. Does that make sense?
Yes.
Okay. So you start out with the length of this line. You look at where this point is. Just say that this is A. Okay, so something that you know about A. What's something that you can know about A right away? Well, A is less than 1, but you can approximate it with 1 later on. And so this point here, B, what do you know about B?
It's less than 1.
Yeah. And you could do the same for this point here and this point here. Let's just focus at this part here. All right. This line here is obvious, is at a 45 degree angle, right? Because it goes from the center all the way to the corner of the square. So that means that both of these shapes will share the same point right here. Something else that you can notice is that because it has to be farther away from both the top and the right sides. Something that you know is that when it's over here, the distance that it has from this side really doesn't matter a ton. Because it really just matters how far it is from this line up here. Does that make sense? Because like with here, we could just say it was 1, because it was just how far it is away from here. Whereas as you get closer and closer, well then this side starts playing it. All right?
Wait, so it can be 1 all the way up until, so it can be almost 1, basically.
It's almost 1 here.
But not equal to 1.
Yeah. Though as you go further and further out, because you figure that every time what you have is you have a line going out.
So the limit is approaching 1.
Only here. 1's actually the smallest value your line will ever have.
So it can have 1?
It can. Because you figure like when it gets here, because picture that you say that this line here is 1.
Mm-hmm.
Actually, that's not a good explanation. If everywhere it were 1, then you would just have a circle.
Mm-hmm.
And what happens here is that because, even if it's like a distance of greater than 1 away from both sides, because of the fact that it's at an angle, it can still be greater than 1 potentially.
So
because it's on the hypotenuse.
Right.
So it's halfway between the hypotenuse, and the hypotenuse is larger than the sides.
So it's
Well, it's actually not halfway through the hypotenuse.
Well, still.
Right. So something to kind of notice is that basically what this thing does here, this thing does here. So what this does in relationship to the top side, this section here does in relationship to the right side. Yeah.
So does C, as we shall call the diagonal,
Sure, we can call this line here C.
would C then have to be less than the square root of 2?
It would, but not quite for the reason that you're thinking. We had that same thought, and it doesn't quite work out that way, and I'll show why.
Okay.
Okay, so if we do it where this should be about halfway across the line, like we just say it's almost root 2 but not root 2, that means that it's 1 away from here and 1 away from here.
Mm-hmm.
But that's not possible because the square root of 2, or almost the square root of 2, is greater than 1. So whatever this value is, it's not, it has to be more than just, almost square root of 2. Because if this is 1, then, almost square root of 2 is greater, so that doesn't work. So, but one thing that I do want to point out is the fact that you can break this up into 8 parts.
Mm-hmm.
And all of these are going to be symmetric with each other, with how it's set up. So we're just going to focus on this part here. Okay?
Yeah.
All right. So we're going to say that whatever point is along here, we're going to call that R. And we're going to call the distance from wherever r is from this line here, we're going to say that that's, what do you think a good letter is? We want to say n?
Z.
And you. I gotta show.
Because if we do z, we have to mark another one. So
Let's-
we'll say that any line that goes from somewhere on here to somewhere over here, so r is less than n. We'll say that there's some line here called n, all right?
Yeah.
And then in that case, we'll say the line from there to there, r is less than
P.
p. All right. Okay.
He is that one up top.
Okay. So another thing we know. So I guess we're going to make this our r. R should be equal to, actually r squared should be equal to, you know that there will be a y value and an x value. So it equals, so r squared equals x squared plus y squared, Pythagorean theorem, right?
Mhm.
And we can find out what x squared and y squared are, because x squared will end up equaling 2 minus n squared, right? And y squared will equal 2 minus p squared. Does that make sense?
Mm-hmm.
So we can rewrite r squared, we can rewrite what it's equal to as 2 minus n squared plus 2 minus p squared. All right?
Mm-hmm.
So far, so good. Okay. So, something that we can then do is, because we're just looking at this section, we already said before that what's important here is the distance between the top and wherever this line is. So P is actually what's important. So, you know that no matter what, R is going to be less than N is, right? But it should be almost equal to what P is. So we can make an approximation and say P squared is equal to 2 minus N squared, sorry, the square is wrong, squared, plus 2 minus P squared. Do you understand why I can do that?
No.
That's approximately equal. That's the right sign, right? Approximately
Oh,
equal.
Yeah.
Extremely equal.
oh, yeah, okay, yeah,
For this section here.
yeah.
Okay. So we subtract this part here over. We get. I'm gonna start erasing stuff. 'Cause now it's in my way.
I'm gonna forget what it was.
What? So you get p squared minus 4 minus 4p plus p squared equals 2 minus n squared. All right? Everybody good on that so far? So then, something that you can then do is, as you can see, these cancel out because the negative sign carries over. So you get 4p minus 4
Oh.
equals 2 minus n squared. Still good? Okay. So then, from there, what you can do is you can subtract over, so you get p is equal to, and actually you can then put this back if you want. You can turn this back into x squared over 4 plus 1.
Where did the 2 minus n go?
It's the same as x squared.
Oh. Wait, so. Okay.
Okay. So you know your p value, and so from this you can actually find your y value, because I can rewrite this y equals 2 minus p, right? So that means that y equals 2 minus x squared over 4 minus 1. So y equals 1 minus x squared over 4. So from B to C, you now have a formula to find y. And you have another line, which you can use as another bound. And you know what that line is?
Oh, yeah.
Square root of 2. No, I mean, there's a formula. What's the other line that bounds it? We're just looking at that one part of the arc. What's the other line that bounds it? It's a really simple. It's a linear polynomial.
How is it really simple then?
A linear polynomial means it's something to the power of 1.
Yeah.
Okay.
It is x.
Wait, for which part of the arc?
This line here.
Oh.
So it's bounded by this and by this.
Oh, okay.
So you have two different equations for y, right? And you know that your first bound is at x equals 0, because you're going to need to integrate, right?
Yeah.
And so how do I find my other bound?
2 squared plus, no, square root of 2 squared plus, okay. But if it's the
Well, if you have what? It's not y equals 0, because we're just looking at this one section here.
Can't you do like 16 minus the,
16
because
minus-
16 is the whole area of the real square, and can't we just subtract out?
X equals 0.
Subtract out.
That's much.
Well, hang on. So whenever you have two functions, you're trying to figure out what their bounds are. What's one of the things you can do to find the bounds? I have two lines. I have y equals 9 minus x squared, and I have y equals 0. How do I find my bounds? Equal. There you go.
So 9 minus x squared equals 0.
Well, for when it's a semicircle like that. For this, you have 1 minus x squared over 4 equals x. And so from that, you can find your other bound. Does anybody know how you find your other bound?
Well, would you first... Oh, wait, why do we have an x on both sides?
Because we set this equal to this.
Yes, but we shouldn't have... We should
Okay,
have one
then,
x.
then what should I do?
Move the x square... Add x squared divided by 4. Wait, no. Yes.
Plug it into the calculator.
That's a good idea, but no. Subtract x. No, never mind. Yes.
Multiply everything by 4? Okay, now what?
Divide by x.
Divide by x, well, then you
Right,
get 4
no.
over x. That makes it more complicated than it already is.
So, add x squared.
What?
Add x squared. Wait, no.
X squared, then you get it over here. Okay, so you get 4 equals 4x plus x squared.
Divide by 4? No. Wait, can you take the x? No, because then you'd still have an x.
Subtract what?
Negative 2 times square root of 2 plus 1, or 2 times square root of 2 plus 1, minus 1.
What?
The answers.
The answers are
Unless that's not negative.
Okay, so you subtract it over, you get 0 equals x squared plus 4x minus 4. Yeah. And what were you saying your answers were?
On the calculator, it says -2 times. Wait,
What?
-2
Right,
squared root of
bigger.
2.
You can move the camera if you need to.
Wait, it only told me.
Wait, how do you solve for x?
I just plugged it in.
No, don't do that. Come on, look at the form of it.
You just use the really long -b plus or minus.
All right, yeah, I don't really care as much about names, as long as you know what it is. So, -b. So I'm assuming you're saying that your 4 is b.
-b plus or minus the square root of b squared. B squared, 4 squared, minus 4, 1, -4, all over 2. Correct? Yes.
Yes.
Are you in the shot now?
Okay. So you calculate this out, you end up getting x equals, what are the given values you get?
16 plus 16.
Take out the 2, that's
2
4.
squared No.
I know. So which one is the actual value? The positive one. Why is that? Because you can't have a negative
Length.
yeah.
Well, you could.
This is
but
coordinates we're talking about. It has
But
nothing to do with
we're in
length.
the positive coordinates.
We're in the positive coordinates. So
quadrant. Positive quadrant.
positive quadrant. Very good.
Positive. Quadrant 1.
So you found your other bound now, right? And what was the formula we were using again? Or what were the... So, and what should I write in the integral? What should I write?
You subtract the 2 equations
Subtract them from what?
from each other. Like one from the other.
Does that make sense?
If you subtract an equation,
Does that make sense? It's not a trick question. I'm asking you. Does it make sense?
Yeah, because the y equals x squared is a bit underneath the portion where we're measuring in the bit underneath and not.
So, which one are we subtracting from which?
You're subtracting x from 1 minus x squared over 4.
Okay. So you got 1 minus x squared over 4
Hey, I'm making up.
minus x. Dx. And that finds you the area for what?
the one,
The one little wedge?
and it comes by 8 into the answer.
Wait, why is it? How did it get at? Simple.
Math is all about simplicity.
No,
you just gotta
it's
find
not.
it.
It's not simple though.
You know what's fun? Physics.
No,
It's
so much fun. It's so much fun.
This is not fun.
This is fun too. Everything's fun. Well, lots of things are
This
fun.
is more fun in the morning.